Hi friends, welcome to this lecture on unification technique in artificial intelligence. So in this technique we are going to discuss what is unification, and then we will see what are the conditions to be checked for applying this technique. We will also discuss example and algorithm for solving the problem. So unification is basically finding a substitution to make two logical atomic expressions identical. So this plays a very important role in solving some logic programming problems. For example, SMT problem solvers are widely used to do software testing and problem analysis and problem verification. So we apply substitution technique to replace one variable by another term. So we try to make two logical expressions identical, two atomic expressions identical. Let us consider that we have this series of terms or forms. So we can say this v1 is a particular variable, and we have v1, v2, etc., vn or some variables, and we have terms t1, t2, etc., tn, where this v1 is considered as a distinct variable. Each v is considered as a distinct variable, and we consider each term has some kind of binding for this variable v1, v2, etc., vn. So when we are trying to apply this substitution technique, we should check whether it is in proper form. So we have to check some conditions for that. So the variable vi should not appear in any of the terms t1, t2, etc., tn. So if that is the case, then we can say that the given atomic expressions are in proper form. We can proceed to apply this substitution technique. So it decides what value to be assigned to a particular variable to make two atomic expressions identical. So before applying this technique, we should test these conditions. We should check whether there are same predicate symbols in both expressions, and also we should check whether the number of arguments in both the expressions are the same. And if unification fails, then that means any of these conditions are not satisfiable. So that means if there are two similar variables in the same expressions, or number of arguments are same in both the expressions, then unification will fail. So let us discuss this algorithm now. Let us consider two literals L1 and L2, and this L1 and L2 now we have to consider for making them identical. So we check initially whether these two literals are looking identical. So if that is true, then we can return null. If L1 is a variable, say L1 occurs in L2, then it returns failure. We have to check the condition whether the predicate symbols are same in both the expression. That condition also we should write before applying this technique, and we should also check whether the number of arguments are same in both the expression. For that also we have to test the logical condition, and then we make this process return unifier if this condition fails, right? So if they are not identical, we call the unification function, unify function, to apply the substitution for making those two literals identical. Otherwise, L2 may occur in L1, right? That condition we have to check. If that's the case, then it returns failure. Otherwise, it calls the unifier, applies the substitution to make them identical. So if all these conditions fail, then it returns failure. So this is the actual algorithm to be applied. Let us now discuss an example for this unification technique. So this technique is widely used in inference problem to solve inference problem. Even when we apply resolution technique, we apply this unification technique to make two logical expressions identical sometimes. So for example, in question answering, suppose you have a statement like X is king, right? So when you are assuming that X is John, then we have to substitute John to that particular variable X to make the expressions identical, right? So the expression will become John is king. Like that, we are trying to make the expressions identical in question answering. So before we apply this technique unification, these two expressions are in this form: p of x comma f of y. So p is a predicate symbol, x is a variable, f of y is a function of this particular variable y, let us say. And we have another expression, that is p of a comma f of g comma z. This a is a term, and we have f of g of z, another term. So now we have to apply substitution in this equation 1. So now to do that, what we do, we assign the value a to this particular variable x, and we assign g of z to this particular variable y. So what do we get now after the substitution? We get p of a comma f of g of z for equation number 1. For equation number 2, we are getting p of a comma f of g of z. Now you can see these two equations, or two expressions, are looking identical. So this is an example to show how we generate the result of unification. Thank you guys. In the next lecture we will discuss with example and the problems, problem solving approach for resolution technique. Thank you guys.